Okay, let's start. Good afternoon, everybody. You are all very welcome to the second Discover Us webinar. Today is my pleasure to welcome Dr. Rute Sofia. She will be our speaker today. She is the Industrial IoT Head at Fortiss, the Research Institute of the Free State of Bavaria for Software-Intensive Services and Systems. She is also invited Associate Professor of University Lusófona de Humanidades y Tecnologías and Associate Researcher at STAR, the Instituto Universitario de Lisboa. Her research background has been developed on industrial and on academic contexts. She was co-founder of COPE Labs, a research unit. She was scientific director there and currently senior researcher. Today, she is with us to present the CODECO framework. She is coordinating the project, and she will let us know how CODECO is contributing to the future edge cloud continuum, enabling adaptive and elastic data processing, computation, and networking for optimal efficiency and ease of use. Please, Rute, could you please take the floor? Thank you so much.
Thank you, Maria. So I'm going to share, hi everybody, I'm going to share the slides. So as Maria said, I'm going to present you a project that Fortiss is coordinating, so Cognitive Decentralized Edge Cloud Orchestration. The webinar, so at least I've prepared the presentation for circa 40 minutes, but it is feasible, so as you will see, so let me just quickly, as you will see in the agenda, we have, let's say, different things that I'm bringing to you about the project. So this will be a technical webinar, but I will give you an introduction to the project, but also to other aspects. So the project itself is about the development of a framework, but of course it brings other assets. As we are a small group, so what we are proposing in terms of the webinar is that after I finish each part, I will ask if you have some questions, and I hope that we can have some minutes for that. But we will reserve also some minutes for questions in the end. So in terms of CODECO, so CODECO is a project funded by the European Union, so under Horizon Europe, and under the topic Cognitive Continuum. So in this topic, there are, I believe, 5 other projects, very similar. And so the topic focuses on the development of an intelligent IoT edge to cloud support for applications that we run today in the internet and so on IoT. And in terms of what we proposed in CODECO was to develop, let's say, this intelligent orchestration framework based on data, compute, and network. So why? So the vision behind this is that this so-called continuum, so all this end-to-end environment today is becoming more complex, as we all know. So we have the internet, as we had over the last decades, but we also have more mobility, embedded devices, different hardware architectures. We have high capability computing on the cloud, and this brings new challenges. And in terms of applications that we are running, or that we are using today, on the internet and on IoT, we have very different applications. So applications that are time sensitive, but we have also applications that are tolerant to delays. We have critical applications with the need to have a tight control in terms of requirements, but also in terms of security or compliance to specific certification. And so in this environment, what we decided in the project to do was to give an answer to some challenges that we have, and which you see on the left-hand side. So basically the fact that we have today these smart environments, highly decentralized, where the applications are also distributed. In terms of applications here, I'm focusing on micro-containerized or applications that are based on microservices, so containerized microservices. Of course, there are other architectures, but in terms of IoT world, that's the largest portion of applications. So we deploy applications across edge to cloud, where the edge can be and is our end user device until the cloud. And this implies that we have an infrastructure in terms of computational resources and also networking resources that is very, very heterogeneous. So, and in this environment, one aspect that we need to cover in this new continuum is actually to ensure that the applications can be highly portable and can support all these mobility requirements. And so in CODECO, we decided to work on an orchestration framework. So we believe that the answer to this is to attempt to try to create an orchestration framework that is able to handle and to manage resources, so to orchestrate resources at the computational level, at the networking level, but also at the data workflow level at the same time, and not focus as we have today so far in most architectures to handle these aspects in a separate way. So CODECO itself, so today I will focus on the framework, on the technical aspects. So CODECO started in January 2023. It will continue until December 2025. So the work that we have developed that I bring to you was developed on the first 10 months of the project. And I will also explain you what is happening now and the latest findings. And in terms of assets of the project, so you have on this slide what the project brings. So we bring, of course, this framework, which is an open source software framework, but we also bring other assets. So for instance, we are developing some additional applications because of the use cases that we are deploying. We are also creating or expect to create a training database related with these new orchestration approaches, how we use this, for instance, to do experimentation, what can we use, how do we generate load, etc. And the code itself is under an Eclipse repository, so an Eclipse project, which you can check, and where we already have a first early release of some parts of CODECO. So we also, CODECO is, as framework, we are going to validate it and to experiment it and to demonstrate it across different use cases that relate with this next generation of IoT applications. So that's what you have here, what we call from P1 to P6. And today I bring you also a perspective on two examples. In principle, if time allows, I bring two examples of what we are building. So the use cases are still in a very initial shape. So in other words, the use cases started to be deployed really from an operational perspective 4 months ago, but I can give you some information about the status. So let me then go more to the technical part and to explain you, to bring you the overall concept. So as said, what is this clever or adaptive orchestration framework? So on the left-hand side, you have a high-level scheme of 2 edge environments plus clouds or representation, where you see the symbol of Kubernetes. So basically there we have clusters of devices and also other cyber physical systems. So can be bare metal servers, but also regular virtual machines. And on the left-hand side, you have representation of 2 edge environments. So this could be, for instance, 2 different locations. So edge 1 and edge 2. And where CODECO resides as a framework, so CODECO can operate can be on the cloud, it can be on the edge, and it can communicate edge to edge. So basically, CODECO is being devised so that we can support applications that run on an edge, edge to cloud, edge to edge. And the idea is that, so the principles behind CODECO is that there are some triggers done by an application. So this could be, for instance, lack of resources in the infrastructure, or some external triggers to the application. for instance, the users that are using that application are moving, and therefore the application should be moved also, should be offloaded or migrated to another location or to another environment. And that's what CODECO tries to do, to automate this, so these needs, to detect these needs in an automated way, and also to handle all the aspects that are required to create this migration in a way that allows the applications to run in a secure way, and also in accordance with the requirements of the application. So on the right-hand side, you have, let's say, the principles of this dynamic container management or orchestration. So first, there is a part, so one part relates with injection of parameters, so of metrics to the system. So we call this context awareness. And context awareness is handled in CODECO at different levels, so different categories. I will give some examples also during the course of the webinar. And on the right-hand side, you see, let's say, the key aspect of the orchestration, which means, so we inject parameters that are very different in nature, that come from different OSI layers. And there is the need to do a multi-objective optimization. So it's as if we had different graphs, so different snapshots of graphs at a network level, at an application level, at a system level. And what CODECO tries to do is actually to optimize the infrastructure, having in mind that it has 3 layers. So the data workflow, the network, and the computational layer. So in the reference that you have in this slide, you have information about CODECO. So let's say the reference architecture that we developed up until the first 6 months of the project, and which we are now revising. So a new version will be released by June 2024. And you also have information about the code that is available. So in terms of approach, I would also like to highlight that, so these projects are long, of course, and what we wanted to do with CODECO was to have the conceptual, the scientific part, so to study, to analyze how could we adapt better the orchestration in federated mobile environments, but also to be able to bring to life this concept fast, so in an agile way. As I explained, CODECO is open source, and therefore we decided to split the CODECO development into 2 parts. We are currently on the first part that relates with CODECO in a single cluster operation. But of course, the design of the architecture and of the components takes into consideration already the federated clusters deployment. The use cases are also focused on supporting federated cluster environments. But this means also that if you are also interested on that, I would say that is the second part of CODECO, and it starts in July this year. So I'm going now to start with information, more the technical information, and then there will be, I think that we have some time, okay, for questions, because this may be a lot of information. So CODECO as a framework we have created a framework that is composed of different components. You see them on the left-hand side. So the representation that you have here on the left-hand side is basically a high-level depiction of CODECO. Is not a software, let's say, architecture. So there are components, as I will explain, that reside on the control plane and components that reside on the service plane. But this gives you a perspective, and I will enter into more detail in the next slide about what components, what parts compose this orchestration. So we have a component called ACM, Automated Configuration and Management, that is actually the entry point to the user. So it means that, for instance, if a user wants to use CODECO, the user here in this case is a developer and is deploying an application, wants to deploy an application across edge to cloud. And of course, the idea is that the user does not need to know where to deploy it. So as we do today with Kubernetes, basically there is some configuration which we enter, etc. And on this case, CODECO actually brings another level of automation to Kubernetes. So let's say that the user, in fact, does not see the 5 components or 6 components of CODECO. In fact, the user just sees, let's say, this wrapper, okay, ACM. ACM is the controller. And we have also, so basically this relates with the configuration, setup, but also a few other aspects that I'll explain in a minute. Then we have a component called MDM, Metadata Manager, that brings the perspective of the data workflow to Kubernetes. So MDM, for instance, can do discovery of relations between so data and the application, so the containerized application that we are deploying, can also provide additional information, so some metrics, for instance, analysis of how stale is the information being kept on a database. And in other words, brings some parts of data observability to Kubernetes, which Kubernetes cannot handle today. So PDLC is the brain, let's say, of CODECO. It relates with so using AI to provide a finer grained estimation of where the application should be deployed. So the application and its containerized microservices. And SWM is a new scheduler that we are deploying with CODECO. So a new scheduler that can be used with Kubernetes, but is so brings some advantages when using the other components of CODECO. And on the network part, we have NetMA, which is a component that brings, let's say, the network world. So network metrics, information about the infrastructure, the networking infrastructure, the links, the paths, the routing, etc., to Kubernetes. So these components, they are being developed independently. So in other words, they are also containerized, and they are composed of subcomponents, also container images. They can run, so they are not dependent on each other. Of course, they can run better. So in other words, we can use the scheduler just with Kubernetes. We can also use, in principle, the network part just with Kubernetes. So the purpose was, of course, that we would create a framework that is optimal or provides an optimal scheduling or rescheduling of applications if used together. But the components can also be used with the current Kubernetes. So where are we currently? So this is now a broader depiction on of the same components, and so the what you see in green and or red or yellow are basically the software parts that we are developing. And what is in green means that you can already play with. So there are some parts that you can download and play with to test. For instance, the machine learning part, which I will also explain in a minute, is we already have some proofs of concept that you can use. And the red parts are, of course, aspects that we still did not integrate. So the overall CODECO framework, the first version, first release, as a whole, that can be used all together, will be available by the end of June this year. So let me go into more detail now into each of the components. So as I said, ACM is what the user sees. So let's suppose we have a developer wanting to deploy an application, for instance, with 4 containers. So we use in CODECO the terminology of Kubernetes. So that is seen as an application group. And these 4 containers, they are, let's say, so the aim is to deploy them in the best possible way based on an available infrastructure. So for instance, this could be rented cloud space that the user has access to, could be some local environment, a cluster or multiple clusters that the user has. And as you see on the left-hand side, what we do is that ACM hides the other component. So in other words, does the installation, okay, so that the user doesn't need to deploy each component, every single component on its own, but it also does a little bit more than that. It brings information from the user to the CODECO system. So we call that CODECO application model. So in other words, when the user sets up an application, what we are doing that is also new in comparison to what Kubernetes does is that we actually give the system a view of the application requirements at the data, network, and computational level. So for instance, Kubernetes checks or proposes to have requirements in terms of CPU or memory, or could be energy that the application requires. We go a step further, propose to also give information about, for instance, security aspects that the application may need, or quality of service classes that the application or its microservices need to be guaranteed with. And so the example that you have here is a high-level representation of what we call, so this CODECO application model, which is basically an interface currently done in YAML, in the YAML language. So the user will have access, right now it's basically deployed on the command line, but the user will have access to this via dashboard that is being deployed in ACM. And so, for instance, the user is invited to answer a few questions about the application that he or she wants to deploy. So, for instance, how much CPU is required, or what is the tolerance to failures, what is the level of security, etc. So the boxes that you see on the spec part, which is the Lila part, they represent input that the user gives to the CODECO system. This is done at an application level, I said, so that we have a global view of what the application needs, but also at a container level, at an image level. So this means, for instance, if we have an application running that has a container that is, for instance, a broker, a communication broker, and so some container that does object counting, for instance, and another container that does that relates with the database, for instance, GraphDB. Then this means that what we write, what the user actually will write, are requirements for the application as a whole, but also for each of these microservices. The pink part that we have here is actually status that CODECO gives to the user. So in addition to deploying the applications, CODECO has a monitoring part. And so this means that it will bring some information about the application, so how the application is running on the system, but also about the overall infrastructure status. So how is the network, how are the nodes, etc. So, of course, what we do is sort of an upgrade to what Kubernetes does. Kubernetes does not have this application view. We believe it is important so that we can really automate the orchestration for the applications in a best way feasible. So another component of CODECO is MDM. So I have briefly explained that this relates with data observability. We believe that this is important because in particular on the IoT Edge Cloud Continuum, everything is about data exchange. And what happens is that normally what we do in these management tools is that we have a perspective of the computational part, and of course we start to have already a perspective of the networking part, so the links or the paths that are interconnecting the compute nodes. But what is usually missing is really this data workflow perspective. And so what we have in CODECO is this component MDM, which creates, let's say, a snapshot of the data workflow for the application group. And that information is brought to CODECO and is used by another component, which you see here on the right-hand side, PDLC, which relates with the machine learning-based orchestration. So the idea is that if we have more information, we can provide a better estimation on where the application should be deployed. So an example of something that MDM can do is, for instance, analyze the compliance. So for instance, if an application has compliance requirements, for instance, the application needs to meet GDPR, then, or some specific parts of GDPR, then the MDM helps in understanding which nodes would be compliant with GDPR, and therefore we can rule out nodes that are not compliant with GDPR to be part of the infrastructure, right? The graph that we will use as basis to deploy the application. So the core part of CODECO, as said, the orchestration is PDLC. So PDLC relates with this intelligent and profile sensitive component. So what is this? So on this representation, what you see in green is what we call PDLC. And in blue, you see the other components of CODECO. So three of these components collect data. So MDM, as I explained, collects data from the data exchange perspective, so data observability perspective. What kind of data? For instance, age of information, freshness of the data, so the latest time data related with application was updated, and compliance, for instance. ACM collects information, as I explained, about application requirements that the user provides, and also collects information about the computational part, for instance, RAM, CPU, energy. So any metric that is available via Prometheus, the metric server that Kubernetes uses, ACM can collect. NetMA collects metrics from the network. So it collects metrics at a physical link level. So this means, so when we have two nodes interconnected, we have, from the perspective of Kubernetes and orchestration of applications, we have an overlay. So this means we connect the microservices in Kubernetes terminology pods. Okay, so we connect them via an overlay, so via tunnels. But there is also a path, a physical path underneath. And NetMA brings some information. So for instance, throughput or bandwidth or latency, but also other aspects, for instance, energy of links. So these are parameters that we are using to create, let's say, some sensitiveness to a target that the user wants to optimize in the system. So how do we do that? So you see here three components or subcomponents. DP means data processing, regular handling of data sets. So normalization, so first, of course, cleanup, normalization, etc. CA means context awareness, and DL means decentralized learning. And in terms of this, what we do is that the user, for instance, maybe the user may want to optimize the system in terms of greenness, for instance, so the use of energy, wants to reduce the use of energy, and therefore this component PDLC gets that information from the model that I showed you, so the CODECO application model, and does an aggregated cost computation for all the nodes available. That cost computation takes into consideration not just metrics at the computational level, but also at the network level. So for instance, the energy spent on the links that are transmitting information. And based on that, we create a cost to the node that the decentralized learning approach uses together with other metrics to propose, let's say, the optimal or the most suitable graph to fill that performance profile. So here you have an example of context awareness. So what you see here is the communication sequence that we use. For instance, we have some monitoring components. We have the controller that handles the context awareness computation and the cluster. So periodically there is some information monitored as you see. So this is independent from the different components. And then there is also, so I would jump to, so that I can go a bit faster. I will jump to this part of CODECO, where basically we generate some aggregated cost. So on the right-hand side, you have an explanation. So the reports of CODECO give you information about the first functions that we are using and validating. For instance, here we would select on this greenness if the user decided that the target profile, so to optimize the system, would be greenness, then the computation that we do in this component would select nodes that would have the least energy expenditure, as said, not just because of the computational resources, but also because of the networking part. Of course, this is not used in isolation. So as I explained, we are using or studying the use of decentralized learning to optimize CODECO. Why decentralized learning? because as explained, CODECO is going to work across multi-cluster environments, federated cluster environments. So while approaches such as federated learning can work for a single cluster, it will be more complicated because of the information that we have, and we can transmit from cluster to cluster to use something such as federated learning. So therefore, we are taking a look, so different partners are taking a look into the different, which approaches could we use? So right now, the partner that is leading this is taking a look into reinforced learning and also multi-agent reinforced learning for the near future. You have already some proofs of concept where we do some recommendations for rescheduling based on the use of reinforced learning. So we also use machine learning to estimate the potential of normal partners or constraints in terms of future resources of the infrastructure. So this is done by another partner, Intercom, and they are using graph neural networking. So, and you also have already some code that you can use to do some tests in different clusters. So while PDLC, what PDLC does is it handles an estimation, let's say, of what the best possible deployment could be. However, it does not deploy, so it does not do any scheduling. We decided to separate these because we believe that the estimation done with machine learning is not sufficient to ensure that we do a good deployment. So the scheduling and rescheduling of applications is actually done on a new scheduler that can be used, as said, with Kubernetes. And the key difference, I would say, that it uses a graph optimization approach. So basically, it uses a solver to do the deployment of the application, while Kubernetes uses a filter and scoring method. So this code is also available and can be downloaded and tested. And in terms of, so what the estimation gives is that, so PDLC gives, let's say, some information to the scheduler, and the scheduler uses that information to do, let's say, the placement. So in other words, the estimation is also another set of attributes that the solver will have to use in addition to information obtained about the topology, about the application requirements. So and based on that, we do an estimation of the deployment. The scheduler gives feedback, so we use it for a rewarding function to the decentralized learning mechanism, so PDLC. So the final component is the NetMA. So this, as I said, is a component that we use to collect and to pass information to Kubernetes on the network. So there are three key aspects being worked currently. So the first is, of course, bringing the information from the network. So this means bringing information metrics at the path level, at the link level, from an overlay perspective, and also from the true, so underlay network perspective. And the second aspect relates with interconnection of the microservices or the pods in a secure way. There we use a mechanism called L2SM, which provides, so it's basically a tunneling mechanism on layer 2 that provides secure connectivity across pods. And the third aspect, which is going to be more important when we reach the federated clusters part, relates with exposure of information. So in each cluster, we have these parameters that we are collecting, but of course, from cluster to cluster, there may be the case where they cannot be passed from one cluster to the other due to specific service level agreements, for instance. Therefore, we are proposing to use a protocol, so standardized protocol, ALTO, that is being driven by Telefonica to do that network exposure. So here you have some examples of metrics to make this a little bit more clear. So right now, of course, CODECO is being created in a way that other metrics can be monitored and used, but we decided to create, so to have an agreement on what would be a meaningful or reasonable set of metrics for the data part, for the application, and for the network. And so you see here some of the categories of metrics that we are collecting. There is a concrete list of metrics, and the code also already has this in the deliverables of the project, in particular the deliverable that is cited about the architecture and about the early code. So for instance, as I explained before, for data, this would mean age of information or freshness. And for the network part, we have bandwidth, node degree, latency, etc. So some measurements done at the tunnel level, so at the encapsulation level, overlay, and metrics also collected at the physical level, because we believe it is important to also bring some information about not just the tunnel that connects these microservices, but actually about the conditions of the network in between, so the routing part, for instance, and how that impacts the tunnel. So I would now focus, I'm going to give an example of a use case. Time is also, so I think time is also a bit tighter. So let's keep the questions to the end, okay, so that I can explain you. As I said, we have 6 use cases. In these slides, which I assume Discover US will circulate, you have information about each of the use cases. There is already a deliverable describing in detail actors and equipment expected to be used, etc. There are also a few white papers describing the use cases, so that we have been doing about this. But let me give you just this first example so that you understand. So for instance, one of the use cases we have is related to smart cities, is being deployed by the University of Göttingen together with the city of Göttingen, where they have some traffic intersections being monitored with cameras, and where they have an edge node that does, let's say, analysis of the data collected by cameras. And so this is regular sensing environment. And CODECO in this case, so you see here, for instance, on these explanations, on each of these intersections, there is the definition of a cluster. So right now, each cluster consists of 2 to 3 nodes that are then coupled to the data sources, so the cameras. And the idea is that CODECO, so where is CODECO? CODECO is running on these worker nodes, and it can also be running on the cloud, okay, but in this case is running really on each of these clusters. And what CODECO does is that it's based on the analysis of the resources, of the application usage, and also of the resources, it can trigger so a change of the processing tasks to another worker. So for instance, why? In this case, for instance, what the partners are proposing is that, for instance, if we have some lanes and one lane has heavy traffic and the other does not, this means that the cameras that are on one side and the other, and the edge nodes that are aggregating that data, so they have different loads. And so the load can be better distributed to the cameras that are on the lane that has less traffic in an automated way. And so that's what, for instance, CODECO could use. So we have also some additional examples that I'm going to jump, but I would, in particular, the one from the Universidad Politécnica de Madrid is very interesting because it relates with the use of energy assets, so energy data sets. To almost conclude, I would like just to give you some input also, in addition to the code, what can you do with CODECO? So one part is, of course, the code. What you see here is a repository that we already have. All the repository has, let's say, already parts of this code with specific explanation on how you can download the code. So we have, of course, images that you can run, so you don't need to compile things. You can just use it on your own cluster, on your own machine, with an emulator, for instance, with Kind, for instance, and you can run and test some parts of CODECO. There's also a data generator that we created exactly because there were metrics that we did not have yet, and which you can download and play to collect data. So what it does is that it generates data from the infrastructure based on the structure of CODECO. And this allows us, for instance, to play with different machine learning components. Otherwise, we could not do it before the code. There's also an experimental environment. So meaning basically CODECO also has an asset which is being driven by Athena, which is a pipeline that you can use to test the CODECO components. So in addition to, let's say, so to automatize all the operation that we need to do when doing experiments. And if you check here, so our intention is to have this running in EdgeNet, which is an experimental network with Kubernetes, led by Lip6, so in Paris. And, but of course, this can also, meaning the idea is that we can run this pipeline across other large-scale experimentation frameworks that relate with the use of Kubernetes. So you have here examples. So we have our own shared cloud space, but also Cloud Lab, for instance, or Slices. These are experimental environments where you can test the CODECO framework. So we have some videos that you can use, also have already some components installed, so not everything. And the advantage, of course, is all this automatized experiment. You have load generators and you can visualize the results more easily. Okay, so finally, so now my last slides, we are starting, if you are interested in engaging more and understanding not just using the code, but how you can engage, we are starting an innovation and research community engagement program. So this is not an open call program, it's really an engagement program that CODECO has with awards. It starts in April, is led by partner Innova, Mais, and so there are a few steps. Okay, so for instance, what are we going to do there? We are going to develop some demo camps, some hackathons together with partner Eclipse across a few events. So for instance, the next one is EU-fundd, so the Connaissance workshop in Brussels, in Belgium, sorry. And DevCon, we also expect to go to the US with Red Hat, with the Red Hat Summit next year. So, and on these events, we are targeting a few stakeholders from CODECO for experimenting and bringing also new ideas. So I thank you for your time, and this is my last slide. Thank you.
Thank you very much, Ruth, for all your interesting talk. Maybe now it's time for questions. Questions can be made through the Q&A chat, or if you raise your hand, I could open the mic. So we have one question ready by Cohen. He says, can you give an example of how you model energy consumption as application requirement?
Right, yes. So it's not so much energy consumption, right? But it's actually so for instance, the user, what we are doing right now is something very simple, okay? Deterministic is like the user has a scale and the user says, I don't want the system to go beyond this percentage, okay? And what we pass to CODECO is, of course, that percentage, we transform it, okay? And basically, we measure on each node, we measure, for instance, the link, the total energy spent on transmissions, okay, on the node, but really, so not at the virtual machine level, but actually at the node level, okay, kernel level. And we measure also the node consumption, the energy. Based on that, we see whether the nodes are appropriate or not. So the user basically just provides a set of requirements, which right now we are doing like a simple scale, okay, 5 levels, nothing else. But this, of course, in the future has to be adapted. Right now, we just want to play and to try to understand up to which point when we do this and when we use these costs to the system, we still keep the system stable, okay? Because this was never done in Kubernetes. And when we scale, so right now we are playing with something like 5 nodes, 6 nodes. So when we scale to hundreds or to thousands, then this may create issues that we cannot foresee yet.
Thank you very much. Rosa Badia says, hi, thanks for the interesting presentation. The RL models will be able to be retrained based on new data? Hi,
Rosa. Nice to see you, hear you. Yeah, so basically the models, so there is a report that also explains this is Z2CAT that is driving, okay, so the reinforced learning part. basically, actually they are retrained, okay? So there is a profile created so that, for instance, if you have another use case, another data set, then you can use that profile and model the code that we have so that you can use it with new data. Okay, so in fact, we have to do that because we have 6 use cases that are very different in nature, completely different parameters. And so the colleagues that are creating the decentralized learning, they so have to cope also with the use case data sets. And this was the way that for now we found to be able to use this with different sets.
She says, thanks, it's very interesting. I had a question related to the metadata manager. You say that the aggregation is done through a coherent graph model. Huh? So can you explain a little bit more how this aggregation is done and how difficult it is to provide a common semantics, no?
For the metadata manager?
Yes.
Yeah, so the metadata manager is so being developed by, and actually it is already a component, okay, quite, sorry for that, I'm just browsing there, quite solid from IBM. And so IBM basically had a product, okay, called Pathfinder, and MDM is open source software. So basically there, in terms of, notice that right now what we collect in MDM, so I was just going there, so it still does not collect, for instance, the network data that is not there. So I just wanted to show you. So basically you see here, so maybe I can show just here, okay? On MDM, you have, let's say, 3 components, okay? The API is, let's say, the component that actually does this semantic composition, okay? So collection of the different data, okay? So how is this currently being done? So I believe there are connectors, okay, for Grafana and so on. So additional connectors. And of course, they have a translation done on that for specific semantic models. So now let's suppose that we need a new integration of a new catalog or integration, for instance, of, in the case of sensors, okay, of Web of Things semantics. Then basically a new connector would be created. And the MDM code is already ready, so that's what you have there as connectors, is already ready to do that integration. Now, the linked data, okay, so the part where we do, let's say, the semantic composition, right? So for instance, what is the relation of the data and the data workflow? That's part of the engine that you can check, okay? So far, okay, so no problem, because this is basically a regular snapshot of the system, okay, and then deployed, so each object deployed in GraphDB, and then linked, okay, based on specific categories. So right now we are not looking into something like cross-sector data where ontologies are required or something like that.
Okay, thank you. Very interesting. More questions? If not, you see we are on time. So I wish to thank again Rute for sharing with us all your info about CODECO. And maybe I can share with the attendees kind of contact point or email address where they can ask for, no?
Yeah, of course. So I think the slides have, so contact point, of course, mine, you know, CODECO also has, you have the site, you have the links there for contacting globally, okay, the project. And the slides, of course, I believe they will be shared by Discovery with us. So
presentation that is being recorded.
Yes.
Okay, thank you very much for being so kind to share with us your presentation, and thank you to the attendees also for being today with us. Okay.
Thank you for the invitation. Bye.